Okay, lesson 1 starts with a quick little review of what we've already talked about. So points, we know that we draw those with a dot and we label them with a capital letter of some sort, and then we can call that point, capital P. And the dimensions of a point, since there's absolutely no area to it, there's nowhere to move, it is a 0-dimensional item. A line, and this line is missing its little arrow, isn't it? A line goes on forever in both directions. How do we name a line? We'd have to know a couple points. Now, there might be a ton of points on your line, A, B, and C or something. So to name the line, you're just going to choose any two and put the arrow symbol on top. Any two and put the arrow symbol on top. It doesn't matter which two and it doesn't matter which order. The other way to name a line is if there's a lowercase letter, you could stick a lowercase letter towards one of those arrows and call that line N. And on a number line, it just takes one number to tell us where we're at, so we consider that to be a one-dimensional item. On a plane, we're out of capital letters and we already used lowercase letters, so maybe a scripty or a bold letter. So maybe we'll call this plane E. Plane E. Another way to name is if you can find some points that are on a plane. So if those are points A, B, C, and D. Now, the one thing is that we only want to name our plane with 3 points. I would not want to use all 4 of those points. And I would want to use a triangle's worth of points. So if I used A, B, C, that might not be a good call because those look like they might be on the same line. But I could call this plane A, D, B, because that appears to make a triangle, right? And so that would be a good way to name that plane. Order of the letters doesn't matter as long as it makes a triangle. And on a plane, we have an X and a Y axis, and so we say that that's a 2-dimensional surface. When we're drawing a ray, we should always see a point at one end and an arrow at the other. And we name it using that end point. Any capital letter will do, but I'll go with A this time. And then we just need some other point on that ray. And if there's many possibilities, here's X, here's Y. All you're going to do to name that is you're going to always use the end point first. So I would have to name this ray A, and then I name another point that it goes through. I could choose AY. I could also have chosen AX, because that also shows that it's going to go infinitely through the point X or through the point Y, same thing, right? But it has to start with A and it has to have that little arrow on the top. A segment is named by its 2 end points. If that's a P and a Q, I could call this segment PQ with a bar over the top, or QP. Order doesn't matter on segments, but on rays it does. An angle, the order matters on an angle, because remember it's all about this vertex point. If the vertex is point A here, I could name that angle A. Another way I could name that is by putting a number in there. If I had a bunch of different angles, I could call that angle 4. Now that doesn't mean it's a 4-degree angle, it's just what I'm calling that angle. And then the other way is if we had some other points, we could think about how we would round that corner, right? So we'd need to name those points. Points always named with capital letters. I'll go with P and Q again. And so if I were going to round corner A right there, I could round it by going from P to A to Q. Or I could go from Q to A to P. But notice that always that vertex point has to be in the middle of that name. Now opposite rays, this is a new one for us. Basically, I'm going to start by just drawing a line, and I'm going to put a point somewhere on that line. Maybe I'll call that point A. I'm also going to just throw another couple points on there just so we can talk about this. I'll call them Y and maybe Z. So when we're talking about rays, remember we're talking about starting at a point and going forever in one direction. Well, if you think of the ray that goes from A in the direction of Z and the ray that goes from A in the direction of Y, that's what I mean by opposite rays. So if we wanted to make a definition for that, we would say that they have to share an endpoint, and together they would make a full and complete line. So ray A pointing towards Z and ray A pointing towards Y would be considered opposite rays. If we had one going sort of in this direction, AZ and AX or something, that would not be opposite rays because they have to point in exactly the opposite direction. So they would make a complete line when joined together. Intersections. There's a few different ways that we can think of intersections. We can think of two lines intersecting. Two lines intersecting. Where do they touch each other? Two lines intersect at a point. Another way we could intersect is we could have a plane. And we could have a line intersecting that. So you'd have to picture maybe a pencil going through and stabbing through a piece of paper and coming out the other side. Does that look like a line that's stabbing through that plane? So we say that when a line goes through a plane, it also intersects at a point. That's where they would touch each other, is just at that one point. Sometimes you'll see some dotted lines drawn there, just to show that that line isn't stopping it, but we can't really see it because it's gone under that plane. So whatever looks good to you. And then the third type of intersection is if you think of two planes. I'm going to think of this as like a wall on the front of the room and the floor. That would be two planes, right? The wall and the floor. Where do the wall and the floor touch? They touch all along that little crack, all along that baseboard, right? And then you have to remember that since planes are infinite, we have to think of that wall extending infinitely. Then that intersection would also be infinite. So we say that two planes intersect all along a complete line. It would be infinite. So that's three types of intersections that we're going to talk about. Here's a list of the vocab that they would hope that we'd learn from this first section. Undefined and defined terms. Sometimes it's just impossible to actually say what is a point, but I think we've tried to explain it, so that's an undefined term. A defined term we can actually describe really specifically. Collinear and coplanar points, that's the one I want to focus on here. Do you see how collinear has a word hidden in it? Do you see L-I-N-E is hidden in the word collinear? We should think about lines when we see collinear. Points that lie on the same line are collinear points. So 2 points would always be collinear because you can always stick a line through those, but all 4 of these points would be collinear. How would I draw one that's not collinear? I would just plop one off to the side. That would not be collinear. Coplanar, I'm going to start by drawing a plane. It's pronounced coplanar, and you can kind of almost find the word plane in there. Coplanar. Points that lie on the same plane. So to draw that, I would draw a bunch of different points. Those could all be on the same plane. How would I draw one that's not on the plane? That's a little tricky, but maybe I could try to draw one that looks like it's underneath the plane. That one would not be coplanar. So that's collinear and coplanar. We just talked about opposite rays. Opposite rays go in opposite directions. If point C lies on line AB between A and B, if C is between them, then CA, ray CA, and ray CB are opposite rays. And finally, intersection, the intersection of 2 or more geometric figures. So 2 lines, where do they touch? At a point. How about a plane and a line? Where do they touch? at a point. Remember, the pencil's stabbing through the paper at one point. And then what about two planes? Where can two planes touch? All along an infinite line. So those are some of the good vocab from this section. I suggest pausing now and trying these on your own. The first one is asking us to give two other names for line LN. So step one, find line LN. And that would be this infinite line right here. And we're supposed to find two other names. So the order doesn't matter on a line. So we could say NL. But we could also choose any 2 points on that line. So I could call it LM. Line LM or ML or MN or NM. And then remember, there's another way. Do you see that lowercase b over by the arrow? That's another way that we can name a line, is using a lowercase letter. The next one says give another name for plane Z. Plane Z, so it sort of has this bold or scripted print in the corner. Remember, the other way to name a plane is to use 3 points that form a triangle. So you wouldn't want to use L, M, and N because those don't form a triangle. Those are collinear. We would want to use something like M, N, and P. So we could call this plane. Order wouldn't matter. M, N, P would be one good way to do that. Name 3 points that are collinear. I just mentioned I found 3 that are on the same line, L, M, and N. L, M, N are collinear. They're on the same line. Name 4 points that are coplanar. Well, L and M and N are all on plane Z. Is there one more point that's on plane Z? Look for the other capital letter, capital P. So L, M, N, and P are all on the same plane. On the next one, give another name for ray Vx. And for some reason that didn't show up very well, but that should say ray Vx. And so if we were going from V towards X, this one's a little tricky. From V towards X, we'd be talking about that ray. Now remember, I can't switch the order because the V has to come first. So the only other way I can think of would be to say, well, still start at V, but instead of go towards X, go towards W. I know there's no point drawn there, but remember that we know anytime 2 lines cross, there must be a point there. So if we went from V towards point W, that would be the same ray as V toward X. And so that would be another name for ray Vx. I hope that made sense. Name all rays with endpoints W. So end point at W. Well, we could go from W towards Y, and W towards X, and W towards Z, and W towards V. That's all the rays that start at W. They have an end point at W. Which of these are opposite rays? Well, let's start with WY. If we look at ray WY, which one is opposite that? WZ. And then our other set, if we said WX, points exactly in the opposite direction, WV. So those would be our opposite rays.